So I'm going to do some examples for you because the computation of the difference quotient, that is the simplification of it, is different depending on the type of functions. I wanted to do a couple of different examples for you so you can get an idea of how it works. Oops, got ahead of myself. So this is my first example. Suppose that f of x equals the square root of x plus 1. Find f of x plus h. That's part A. So I'm just stepping you through the procedure of finding the difference quotient. So find f of x plus h. Well, you just take what you had above, and everywhere there's an x, you replace it with x plus h. Okay, so you get f of x plus h equals, always write that part, equals x plus h plus 1. And I just put it in parentheses because then you don't get in trouble like if it were squared or something like that, even though it's not really needed here. So that's the same thing as that, right? Square root of x plus h plus 1. So now B, find f of x plus h minus f of x over h. That's the difference quotient. So find the difference quotient. Okay, so f of x plus h I already found. And it's square root of x plus h plus 1. Then f of x is given right here, square root of x plus 1. So put minus, it's always minus, it's a difference quotient, minus square root of x plus 1. Then there's just an h on the bottom. All right, now you want to reduce this. And the thing about these difference quotients to know is that these difference quotients always reduce. Now, there's no obvious way to reduce anything. You can't cross off the h's here because, for one thing, one of the h's is inside the square root and one's outside. And for the other thing, the h that's inside the square root isn't even a factor of the numerator. So you can't do that. So you want to rewrite this in a different form. And the trick here is you want to be able to combine stuff from inside here with stuff from inside here so that things will cancel, like x minus x, 1 minus 1, stuff like that. But of course you can't just put those together because that's not how square roots work. It's not a times, it's a minus. So the trick is to use, for these is, well, how do you get rid of both square roots? You rationalize the numerator. So that means you multiply this by its conjugate, and then you have to multiply by the conjugate of this on the denominator as well. Okay, so I'm going to write that out here. Okay, so I just multiplied by its conjugate, square root of x plus h plus 1 plus square root of x plus 1, top and bottom. Now in the numerator, that's a difference of two squares. So, right, because they're conjugates. So you get the first one squared, x, square root of x plus h plus 1, the quantity squared, right? And that gives you x plus h plus 1. Then you get a minus, then you get square root of x plus 1 squared, this one here, that squared gives you x plus 1. But be careful of the minus, so I'll put this in parentheses when I square it because I still have to distribute the minus. Like that. Okay, that's just using the difference of two squares formula. On the bottom, don't multiply it out. It's already factored. The denominator is already factored. Leave it factored. That's what you want. So now notice a lot of stuff cancels. You've got x minus x is 0, and 1 minus 1 is 0. Now let me rewrite this because it's getting cluttered. So I'm just rewriting. What's left on top is just the h. Notice h over h cancels and leaves you with a 1. Remember, canceling by dividing leaves a 1. So I get 1 over square root of x plus h plus 1 plus square root of x plus 1. And that's the answer. Don't try to rationalize the denominator. You'll end up back where you started from. So that's what we want, is that. So a couple notes. First, the f of x part will cancel by subtraction once the numerator is put in the right form, whatever that is. Okay, so you want to find a form where those will cancel. So what am I talking about? The f of x part over here is the purple part. This is f of x. So when you put this in the right form, all the stuff that's in here cancels with stuff from here. You see? The x cancels and the 1 cancels because of the minus. So all these things over here that come from this part should disappear. That happens pretty much all the time. And that's what happened when we got to here. All that was, and the other thing is, what you end up with will be h times something in the numerator and h times something in the denominator, so the h's will cancel. That always happens too. If that doesn't happen, you did it wrong. You made a mistake. Okay, so that's this part. After the subtraction cancellation from number 1, the numerator is a multiple of h. The denominator was always a multiple of h because we started that way, right here. And then we multiplied by this stuff, so that's already a factor at the bottom. So this particular h gets canceled out, but that doesn't mean that there aren't h's in the final answer. There's one in the middle here. Okay. All right, that's it for that video.